Welcome to Querying Basics lesson. Here we'll tackle the fundamentals of querying data in PostgreSQL. Today's lecture is particularly exciting as we'll be working with a gaming leaderboard system, a project that perfectly demonstrates the power and flexibility of select queries. Today's agenda starts by the most basic selects you can write, and goes on baby steps to allow you select what columns you want to display. Next, you write queries with data filtering, as you won't always aim to list all table rows. The next logical step is to control and reorder the results and finally paginate them, an important feature especially on query results. Another exciting thing is we'll be using pgadmin from now on, as it will make our lesson more visual and enjoyable. The reason for not using it before is it's important to get familiar with first SQL instructions without much visual aid, so you can focus on commands. And pgadmin is particularly helpful with DQL and DML commands, so you'd always feel compelled to bypass the commands with some clicks. Now that you know what they do, I encourage you to explore pgadmin and find out how it can make your life easier. With all introductions out of the way, let's get started. Oh, but before we begin, let's set up our project environment. I've prepared a GitHub repository at github.com/postgresqlmastery/gaming-leaderboard that contains all the necessary SQL files. Clone this repository or download the zip file to get started. The repository contains three key files: schema SQL that creates our database structure, sample data that populates tables with sample gaming data, and queries that contains the queries we explore today. Let's quickly review what tables we'll be working with. The table players is pretty basic. It contains player ID as its generated primary key, username as unique required string, registration date defaulting to the current timestamp, and skill rating as an integer defaulting to 1000 points. The next table is matches, used to collect hypothetical matches played by our players. So it contains some game types and registers when a match starts and finishes. By the way, the idea is when a match starts, a new record is created with just start time. That's why start time defaults to current timestamps. And end type allows nulls. When a match finishes, the respective record is updated to register the end time. We are just simulating being a certain point in time where some matches have finished and others haven't yet. Finally, match results to register the individual player scores, so it contains foreign keys referencing players and matches.